Hi, I'm Ryan McHugh with Integrated Automation Systems, and today I'm here to demonstrate our ThermalSense product. ThermalSense is our adhesion line temperature monitoring system. With our experience in the insulating glass industry and also working with a lot of the sealant reps in the industry, we've come to a general consensus that the top 3 reasons for intercept unit failures in the field are fourth corner patch, running too cold in the oven, and number 3 is how the extruder is running and the wet out on the units. Now, one of the problems with running too cold through your oven is if you don't catch it at the oven right when it happens, it's the kind of problem that you likely will not catch in your plant. Because once units are racked out of the oven, there's no obvious signs that they were never heated to the proper temperature, which means that you'll likely glaze them into the window, package them up, ship them out of your plant, install them in the homeowner's home, and by the time you know you have a problem, it's going to be when they fog up in the homeowner's home. So now that $10 insulating glass unit that you could have remade easily is going to potentially cost you a few $100 because you got to send a technician out, replace it in the homeowner's home. Our system, since it continuously monitors your process, is going to give that operator who's here all the time the information they need to catch a problem at the source right when it happens. So the ThermalSense system basically is made up of a large monitor with a computer and sensors that are mounted on your oven. You can choose to have 1, 2, 3, or 4 sensors. 4 sensors would be full oven coverage, giving you a top right, top left, bottom right, bottom left. Your units run under the sensors or over the sensors. It picks up the heat profile of the unit as it passes over. Once it clears, it's going to parse out just the adhesion line temperatures and plot them on a control chart. It's very common you'll see a spike at the beginning and the end of the unit. That's exactly what we want to see because the way the oven heats these units is the wavelength of the emitters is going to excite the molecules in the sealant and heat them faster than the actual glass. The reason you see 2 different points connected by a line on the control chart is that we plot the leading adhesion line temperature and the trailing adhesion line temperature. And the units are configurable by you. So depending on what type of sealant you run, how thick your glass is, what type of low E, you can adjust your upper and lower warning and control limits on your chart to decide what is good and what is bad. Now, how does the system alert the operator that you have a problem? One is they'll see that all the units are in a pretty consistent pattern, and then they might see a unit start to go outside of that range. When that happens, if it's within the alarm limits, but just outside of the warning limits, they'll get a yellow light warning them that the unit is still good, but it's starting to get a little bit close to the limits. If it goes outside of the alarm limits, they'll get a red light and an audible alarm alerting them that the unit is bad, that it is either too hot or too cold for your sealant. The other thing that we can do is the system can actually send text message and email notifications. So if you want to have line supervisors or quality technicians receive text messages or emails letting them know that maybe line 1 is running too cold, we can do that. There will also be a piece of software that runs separately in your office on a server or a PC that's going to constantly pull all the data from this system, insert it into a database, and then you would have that for your records to prove that you were running within control at any time. But you also can then set up your own queries to look for trends or issues that are happening commonly, maybe even monitor for maintenance type issues. You might see that you're having to run the oven slower and slower to get the same temperature, which could tell you that your emitters are going bad or maybe that they need to be cleaned. Now, this unit that we're showing today is a travel demo unit. The production unit would be in a metal control panel. It would be mounted up on a pedestal so it's nice and easy for the operator to see, and it would also have a stack light on it, making it real obvious to everybody around the line. If the unit is good, the light would be green. If you're getting into warning zones, it would be yellow, and if it's a bad unit, you'd get the red light and an audible alarm.